Yes, now audible.
Yeah, sorry, I was in mute. So what I was telling is, after session, our videos are uploading automatically into YouTube channel of DURGASOFT. So from there you can access these videos, the demo videos you can see, right? These two videos are already uploaded, the last two sessions videos. So here you can see the demo videos link. So if you click, that goes here. So here you can see all our session videos. Okay. So daily session videos will be uploaded here automatically. So you can go there and you can watch if you miss any session. Okay. So once after regular session, what I will do, I will forward examples and whatever contents I have, right, PDF and documents, all the things I'll forward to you. Okay. So let us start. Okay. So yeah. So today again I want to talk about which all Java frameworks we have and how Spring is advanced or it is providing advantages than the existing frameworks. I wanted to discuss here. Uh, just a minute. Yeah. So basically Java-based applications, I mean using Java or its frameworks, what kind of applications we can build? The one is standalone application. Uh, for building this standalone application, the kind of calculator, right, which is running in a single machine, which doesn't require any database or any other front-end UI, right, which is running in the single machine. By using Sphinx, this is designed. AWT Sphinx that we can use to design such a UI. Okay, in Java we have the support to design this kind of layouts and buttons and all. And for doing basic calculations, simple CoreJava should be enough. So using CoreJava, you can able to build the standalone applications. Okay, and if you want to build any simple small scale e-commerce or any office internal applications like employee management for their organization itself, or any bonus kind of things if they want to manage applications, those kind of internal applications, attendant management system kind of applications, or any small scale LMS applications, learning management systems for their students, if they want to create some courses and if they want to share some documentations. For those kind of things, we can go with simple web applications. For building these simple web applications, you can use J2E. We have servlets and JSPs, we can use them. And if you want to connect with the database, we have Jdbc. Using Jdbc, we can do database operations. Apart from this, to build small scale, right, the advanced versions of the servlets and JSPs from other third-party vendors, there are some frameworks. We have like Struts 1x and 2x, JSF, Java Server Pages, and there are other also which are not really popular. So you can use them along with Jdbc, or you can go with Hibernate. Hibernate also open source. You can use Hibernate also for doing database operations, either Jdbc or Hibernate. for small scale, these should be enough using any Struts framework or Struts or JSF. Okay, by using simple Jdbc or Hibernate, you can make simple web applications. I'm talking about before Spring. Okay, so before Spring, what we have for building web applications, we used to choose Struts or JSF with the combination of Jdbc or Hibernate for building simple web applications. When it comes to distributed application, simple web application means generally we will create it as a single application and we deploy into a single machine or single server using one web server or any application server. Web server should be enough to handle this. So Tomcat kind of server should be enough to run this web applications. Tomcat should be enough. Tomcat kind of server should be enough. When it comes to distributed applications, if the application going to handle large business and if it have large customers, okay, so instead of running the complete code or the large application in a single machine, if I run in a single machine, it may not provide good performance. It may not handle all the operations uh, which are in terms of size. If they are very big, a single server may not handle that many requests. Let's say if you see the large scale e-commerce kind of Amazon, right? It have um, like millions of customer base. So the customers are from many countries. If they deploy single application in a single server and if it is going to handle for all the countries, for all the customers, it may not handle that many users requests. We may see many failures. So for such applications, what they do, they'll divide application into multiple pieces and they'll deploy it into multiple servers. When it comes to small scale web application, they'll build application and deploy into single server, one server and one app will be deployed here. But when it comes to distributed application, will divide it into multiple modules and they used to deploy it into multiple servers in multiple regions. So the app related only, the app module 1, modules wise they'll divide and they'll deploy into multiple regions. App 1 module 2, app 1 module 3. So this is how it used to deploy into multiple servers. Server 1, server 2. So this is all depends on their business. If they have huge business, they may go or they may increase the servers count. Depends on their modules. So for building distributed applications, which support we have here, if you want to communicate between multiple servers in Java by using what you can build such a distributed applications, means we have EJBs. Using EJB session beans, you can have here EJB session bean and that can interact with another EJB session beans. Or we can go with web services, SOAP based web services or RESTful web services that we have, particularly for distributed applications. If you want to break your application into multiple pieces and if you want to deploy it into multiple servers, right, your modules, so you should able to establish connection between them when you want to make calls between one module to another module. If you want to establish connection between them and if you want to make call from one server to another server, from here to here if you want to make a call, or from here to here if you want to make a call, and if you want to handle this distributed transactions and all by using EJBs, we can do that completely. If your application is in Java, distributed application, that too, here if you want to use Java, and here also if you want to use Java based code, and here also if you want to use Java based code, you can go with EJBs. Okay, EJBs are Java components only, J2EE components. But to run this EJBs, here we need application servers. We have to use application servers. Application servers only can able to handle EJB's life cycle, whereas simple servlets or struts life cycles can be managed by Tomcat. Apache Tomcat should be enough. It will have a servlet container internally. That servlet container here, servlet container should be enough. Servlet container should be enough to handle web applications. But when it comes to EJB based applications, here we need EJB container. Who will provide the EJB container? Application servers like WebLogic, WebSphere, JBoss. All these are application servers. Application servers, they will come up with EJB container and servlet container. A distributed application can have web component also. So if it has a web component and as well as EJBs, we can go with application servers. Okay. So in case if you want to make distributed calls, we can make EJB session beans, and from one session bean to another session bean, we can make a call and they can able to communicate each other. Or else, if you don't want to go with Java for two applications or for two modules, you need Java for another module. If you are going with another programming here, so EJBs you should not use, as you want to develop this in somewhere by using other framework. Let's say if you want to go with .NET or any other technology or other language, you can build it. In this case, what you need to use here, we need to build web services. You need to build web service. Here they need to build web service, either REST or SOAP. So for REST based web service they need to build, so that we can able to talk with their services. Using web services also we can build distributed applications. Nowadays mostly we are building microservices or this distributed applications by using SOAP based or REST based services. Okay, so this is how we can build distributed applications. Okay, so here when you want to build a distributed application, what if I go with EJBs, a pure Java based application I want to build, and I want to go with EJBs. So if you want to build application by using EJBs, there is lot of dependency. There is lot of dependency on your modules from EJB. You need to extend many EJB classes. Okay, you need to extend many EJB classes. You need to compile them and you need to make them a ER file, enterprise archive file. And server side you need to buy application server license you need to get, and you have to deploy it there. So if you see cost wise, if you want to build a distributed application, I mean distributed features, if you want for your application, let's say you are building a small scale e-commerce only, but you want to make it a distributed for handling large number of customers. So in such scenario, if you want to choose EJBs for your small business, you need to invest a lot on development time, on developers, on deployment, on servers. Okay, so still if you want to make any changes, change management also very difficult. You need to edit existing components, and again you need to retest. Testing is not simple thing, and again you need to do the redeployments. So for that redeployments, again you need to take green zone. I mean the people who are using the application, they need to wait until their deployments. So this many complications we have if you go with the existing EJB components. Okay, so this Hibernate also came again is EJBs only. Here we are discussing about EJB session beans, and there are other components also for interacting with databases. Those are EJB entity beans. So again is EJB entity beans only. This Hibernate came into the market, and again is this EJB session beans and all other frameworks, right? Spring came into the market. So if I choose Spring, instead of so if I choose instead of this EJBs or instead of this struts, do they need any special server if I want to build these distributed applications? If I choose Spring here, you doesn't really require any application server. Whatever features we have in EJBs. In case if you want to make distributed calls using Spring, we have Spring REST support. Using Spring REST support, you can build distributed applications. Okay, but if you choose Spring to build any kind of web application or any distributed application, they doesn't require any special server. Let's say I build a app using Spring. My application build using Spring framework. My application build by using Spring framework, and to run this Spring, you doesn't need any special container. You no need to buy Tomcat either application server. Your Spring application can be managed by its own libraries. Spring itself, it have its own IOC libraries. Using these IOC libraries, you can able to run your Spring application. Using IOC libraries, you can able to run your Spring application. Either it can be a Spring web application, or a distributed application. It doesn't require any other infrastructure support. Most of them are open source, and you can write into your code. You can keep them into your code by putting jar files. Right? As a framework will come up with some jar files. Just you need to use jar files. You need to use framework jar files here, and on top of jar files, you need to write your code, your application code, and you can run this on its own container called IOC. Okay, so why Spring became popular? Because of these reasons. Okay, so when you go with Spring is lightweight. When you go with Spring is lightweight. Lightweight means it doesn't require any other environment or big library support. You don't need big servers also. Okay, it doesn't require any other integrations. Other integrations in the sense server integrations you don't need to do. Other infrastructure support is that doesn't require. It have all the features internally along with Spring, and you can run Spring on IOC. That's why we say Spring lightweight. If you build applications using Spring applications are lightweight, as they doesn't require any application servers. If you deploy application server, let's say you brought a server machine or Amazon EC2, somewhere you purchased space. Okay, somewhere you purchased space kind of EC2, right? There you purchase some space like around 10 GB RAM and something 100 GB memory you brought, physical memory. Now if you choose application servers, if you deploy application servers itself, they will consume lot of memory from your RAM and from your physical memory. But if you go with the Spring applications, Spring doesn't require much memory. So maybe few MBs required for your jar files and few MBs required for your application. That's all. So little memory should be enough in your server. So that's why we say it lightweight. So you can build lightweight and distributed applications also. Lightweight applications and as well as distributed applications by using Spring REST. So here for using REST, again, do we need any server? No. Using Spring and by using IOC itself, you can able to build it. We have the support from Spring Boot. Using Spring Boot, we can able to build the distributed applications also, which now we are calling microservices. Now we are calling them as microservices, or you can call them distributed services. Distribution means dividing it tasks into multiple pieces. Similarly, like modules. I have a big application and it have multiple modules. Each module you can build it in one service, and you can deploy and you can manage them separately, so that you can able to use separate teams also. One team will work on module 1 and another team will work on module 2, so that independently they can do their development and do their testing. So multiple teams can work parallelly and they can able to deliver multiple modules simultaneously. Okay, that is the beauty of distributed application or this web REST based microservice applications. Okay. So now we started discussing about IOC. So we are thinking that this IOC is a like a server, like a Tomcat server, like a application server. So what this Tomcat server or application servers generally they do, what they will do is they will create instances of their servlet classes or struts classes life cycles will be managed by servlet container. Similarly, EJB classes life cycles will be managed by application servers. But now for building my web applications or distributed applications, I doesn't really require servlets or EJBs. I can build by using simple POSO classes. What I'm saying is here, for your application, for your code, you need to write simple POSO classes only. That POSO classes themselves, they can able to manage whatever EJBs were doing, whatever servlets were doing. Your simple POSO classes can do their tasks. And to run these POSO classes, you doesn't require any special container. You can run these POSO classes on IOC itself. IOC, again, it's a simple Java class. IOC containers are simple Java classes. You can run your POSO classes on again Java library only. So IOC came up with simple library. Using this simple library only, you can able to run your MVC classes, whatever the servlets, or it can be EJB kind of distributed services, whatever it is. You can run it on IOC. That's why Spring became more popular. Okay, what IOC will do, what IOC container can do. So whatever application servers or web containers are doing, the same thing we can do here. IOC, your IOC can able to create instances, of your POSOs, your POSO class objects they'll create. So here, like how application servers are creating EJBs or servlets objects, your IOC container can create POSO class instances. And along with when you build a application, right, single POSO may not enough. You may have multiple POSO classes across your MVC. So one can be your controller, one can be your service, one can be your DAO, and another can be any some utility class. So if you want to establish connection between them, instead of hard coding instances one into another, we inject them dynamically by using dependency injection. So IOC can create instances and it can do dependency injection into POSO classes. What it can inject into one POSO, another POSO class reference it can inject into one POSO. It can inject any default values or system requirements. So while building application, you might need some connection properties, right? You might need another server information, something. So if you need any such information, you can inject them here. So in another words, I can say simple primitive variables, primitive data you can inject, collections data also you can inject, whatever it is. If it required any another POSO reference or any primitive data like string name, right, or long phone number, something if you want to inject, or connection password, username. So those kind of primitives, if you want to pass into any POSO class, you can pass. Or if your POSO class, if it have any collection dependency, if it required the same data in the form of list or set or map or properties, you can do the dependency injection. So if I implement my POSO classes by using this dependency injection, your application will become loosely coupled application. So if I use IOC, my application will become lightweight, and if I use dependency injection, my application will become loosely coupled. So that's why we say, why you are using Spring. If anyone asks why you are Spring is lightweight. Spring is lightweight, and Spring applications are loosely coupled. Spring applications are lightweight and Spring applications are loosely coupled. That's the reason we are using Spring. Lightweight because it doesn't require any special infrastructure support. We can use Spring libraries itself to run Spring based applications. And when you build a Spring application, one layer will not tightly couple with another layer. Tightly coupling in the sense, in future if you want to remove one layer and if you want to attach another layer, if you make application tightly coupled, there will be a lot of disturbance in your code. But if your application is loosely coupled, you can able to remove the layer whichever you don't want, and if you want to improve with another technology or another code, you can able to remove one layer and you can able to attach new layer. That's why it is loosely coupled. I'll tell you with MVC diagram. So when we say tightly coupled and when we say loosely coupled here, so generally we implement server side, right? Server side controllers, and we implement business classes. We implement our business classes and we implement our DO classes. Okay, so here, let's say here my controller class name is class car. Okay, I have a car class. And I have an engine class. Engine is like my business. And I have a fuel class. Consider fuel is like a DO. In general, right, how we make connection between controller to business, business to DAO, we create instances of other classes and we can make a call. Let's say here I have a method. Okay, print fuel. I have one method here, print fuel. I want to call this print fuel method here in start engine. I have one method name called start engine. In this start engine, I want to call this print fuel from this start car. I have a start car method. So whenever I call this start car, I want to call the start engine method. So I want to make call from start car to start engine and start engine to print fuel. So if you want to call, in general, what we do, we create direct object engine equal to new engine. If you want to call another class methods, what generally we do is we create object of that class and using that object reference, we call method start engine. So this is the traditional approach. And from here, if you want to call fuel, here we create a fuel object and f dot print fuel. So now whenever I call, when a user call start car, when a user calls start car method, this start car will create engine class object. Okay, here we are creating engine class object and then we are calling start engine. So this start engine again, it is creating fuel class object and it is calling print fuel. So if I make my application in a similar fashion, if I create my application in a similar way, what will happen? The layers, the DAO layer will be tightly coupled with business layer and the business layer will be tightly coupled with controller layer. The reason is you are directly creating instances of your fuel class. Here, let's say I am using fuel. Here I am using fuel petrol. So in future, I want to move this petrol to petrol engine to, I just want to discontinue petrol and I want to upgrade this from petrol to CNG. I want to upgrade this to CNG. what will happen? What will happen if I want to remove this layer? If I delete this layer or if I remove this layer, first thing what will happen? You will see errors in your engine class, because directly here you are using fuel class name and you are calling the fuel class methods. Okay, so that's the reason these two classes are tightly coupled. If I disturb one layer, another layer will be disturbed. So if you see errors in engine class, then again that errors will be navigated to controller class also. It will impact in car class also. So how we can make them loosely coupled? So to make them loosely coupled, instead of directly creating instances, what you need to do? You need to go with this way. So instead of directly creating fuel, what you should do is you need to create a interface fuel first. Interface fuel type first. You need to create an interface fuel type first. Fuel type. Okay, and here you need to have your method signature without implementations. You know, right? Interfaces will not have any implementations. So you need to implement your fuel class now. You need to implement this fuel class from this interface. Still here I am creating object directly, right? Still here I am creating object directly. So this you should avoid. You should not create object directly. This line also you should avoid. So then how to create object? You need to implement your interface here first, and here you need to keep your interface reference fuel type F. Fuel type F. Now into this fuel type F, you need to pass this fuel class object. This fuel class object you need to pass. How you can do that? you really no need to do that. Spring will create object for this. Spring will create object of this class. I mean whatever line you have earlier here, right? This line. You no need to create object. Spring container is capable of creating object. So this line you can avoid. As this object Spring can able to create. If you configure this fuel as a bean by using bean tag, simple bean tag, if you configure your class, we know, right? Yesterday we see example. If you configure your fuel here, this bean class object will be created by Spring container, so that you no need to create direct fuel class instance. Instead of creating fuel class instance here, we just keep its parent reference. Here, fuel type F. Now into this parent class reference, Spring can inject the fuel object, whichever Spring container will create, right? The same object it will be injected here. Now here my start engine method calling the parent class reference F dot print fuel. Okay. In future, if you want to discontinue this petrol now, and if you want to implement CNG, you can implement it. So whenever you remove this layer, first it will not give you any errors, because you don't have any fuel class dependency directly here. Instead, we are keeping its parent class reference. In Java, it is possible, right? Parent class reference equal to child class object is possible. So that's a reason you need to create interfaces first, and you need to provide implementations. That implementation Spring will inject. Okay. So now I removed a layer, and I'm going to attach new layer, new fuel, which is not petrol, which is CNG. I'll implement a new class. I'll discontinue petrol and I'll implement CNG. Now onwards, Spring will do what? Spring will create this CNG fuel object, and this object it will inject. So if you understand this, what is happening between this business layer and DO layer? These two layers are becoming loosely coupled layers because of dependency injection. So using dependency injection, what we are achieving? By using dependency injection, we are not creating direct instances. We are not creating these direct instances. Instead of creating direct instances, Spring IOC container is creating, and it is passing whichever object it creates, the same object it is passing into your reference. That is possible using your IOC. So if you could able to, if your container could able to do these two jobs, your application will become loosely coupled application. If your container or if your application is capable to do those two, you can able to achieve loosely coupled. And as Spring doesn't require any other container, IOC itself is a container. It is going to create instances and it can able to manage them. You don't need to buy a special server and you don't need to deploy them. So your application will become lightweight. Okay. So let us see an example. Okay. Let me start through the slide. So we are talking about dependency injection. Yesterday we thought about how to create object, right? So basically how to use IOC container. Once again, let us revise this. Okay. You need to create your POSO class. POSO class can be your controller or business or any other utility or DAO class. Whatever it is, we consider it as a POSO class. Okay. Throughout applications, you need to implement POSO classes only. Then you need to configure your POSO class into XML. And you need to load XML into your container. These three steps we have to do. Okay. POSO class, a simple example, a class product, it's a POSO class. Now the POSO class you need to configure into your XML. Okay, you need to configure your POSO class into XML using simple bean tag. Here you can see this is the bean tag, bean ID and class. The class name you should configure here. ID is to call this class if you want anywhere. Okay. So this is how you need to configure your POSO class into XML. Then you need to load this XML into IOC container class. This is the IOC container class application context. So there just we are creating object of the container class and loading our XML file. Here if you see the XML file we are loading into this container class, and this container class will start creating objects to your POSO classes. So how many POSO classes you can configure here? As many as you require for your application. You can configure them into XML file and you just load that XML. For all your POSO classes, it will create objects. That is the first step. Okay, first it will create objects. Then next, it will do dependency injection also. Dependency injection means it can pass the required properties into your POSO class. It can pass the required properties into your POSO class. So here from this, what we understand is another class object is dependency into another class. Okay, I mean one class object in dependency into another class. Like DAOs are dependencies to business, businesses are dependencies to controllers. So one class object you can pass into another class. Not only object, whatever you want. So if you see left side, here if you see left side, I have an employee address class. Employee address class is having a dependency of city. Employee address class I have, it has dependency of city, and here I have a parameterized constructor. So using this constructor also you can do the dependency injection, or else for the city you can create a setter method, set city. Using this set city also you can inject these values. These values from where we will inject? From XML file only we will inject. The injection will be happen from XML file only. How it will happen? Again, create a POSO class with setter method if you want to achieve setter dependency injection. Okay, so create a POSO class with setter method and configure POSO into your XML file and load that into container. See, here I created a POSO class product, and this class product is having a dependency of private string product name, and here I have a setter method to pass the product name into my product POSO class. Just you need to create XML file using bean tag, bean IDP, and class name product class. And to call the setter method, right? Set product name. Here I'm using property tag. Property tags are dedicated for setter methods. To call setter methods, we need to use property tags. Property means setter. Which setter method? So we need to specify that setter method name here. Product name. Set product name method I'm calling, and what you want to pass. I'm passing car here. The product name is car. So the product name is a string data type. So as it is string, I'm using value attribute. Using value, I'm passing my string value here. Then finally, you need to load this it into IOC container. So IOC container will do what? First, it will create your product class object. Then into product class object, by calling setter method, set product name, it will pass the car name. Okay. So let us see one example. Let us see one example for this setter method. So just create a simple Java project. Setter dependency injection. We know, right? We need to create a project first, and you need to add jar files. Later we will see how to do this with Maven also. Okay, using Maven dependencies or using Maven project also you can do it. For now, let's go with adding libraries. Okay, now create a project, add libraries, and create your Pozo class. Create a Pozo class here. So product Pozo class. I'm creating a class name called product. This is my Pozo class. And in this Pozo class, I need few dependencies. Private string product name. And I'll take one more. Product color and the product price. So I have three dependencies in my product class. My product class needs product name, product color, product price. So I have two approaches. I have two approaches to pass this data from XML file. I have two approaches, either by using setter method or constructor. So I'll go with setter now. Create setter methods. Set product name, set product color, set product price. Okay, I have three methods: set product name, set product color, set product price. Finally, I want to print them. So public void print product. So I want to print product data here. Product name is equal to product name and the product color and product price. Okay. So now I have a Pozo class. Pozo class having three dependencies. To pass these three dependencies from XML file, I need support of setter methods for that tree. So I have here three setter methods to inject the respective dependencies. Now create a XML file. I'll just copy it here. So inside resources folder, I have a XML file. Okay, so this is standard XML file. So here you need to create first. Create bean here. How to create? Using bean tag, bean ID. So keep product ID here. Something I'll give car. Class name beans dot product. Okay, so ID car. Any ID you can put here. Now to call setter methods, you can use property and you can pass the properties here. What properties we have? Product name, pass product name, and a value, the respective value for product name. So car name and product color. White color. And price. So we taken this as a string, right? In case if you want to use number also, you can put integer data type. You can pass integer value also. So instead of string, you can use integer if you want. So int values also you can pass here using value only. Between double quotes only you have to pass them. But before passing it, it will convert into integer and it will be passed into int directly. Okay, you don't need to do any typecasting there. So give number somewhere around 55 lakhs. Okay, so that's it. Here I created my bean. Then here I am calling my setter methods and passing my required data. So this is how you can do simple primitive data types, primitives dependency injection. Okay, simple values I need. These values I can pass here directly using simple value. Now load this into your IOC. Okay, this is how you need to load it into IOC container application context, your container reference, then new class path XML application context, pass your XML reference here, and now call container dot get bean of product dot class. So it will return you product class object. Now if you want to print the product information, call print product. So when I call this print product, it should display product name, RD car, product color, white color, product price, whichever given there. Okay, 55 lakh. Run this. So here you can see the product name. These values has been injected. These values injected from your XML file. From here, these values injected into this class. So this is what we call dependency injection. So using this dependency injection, simple properties I am injecting here. This is not only meant for injecting simple properties. Instead of simple properties, you can inject another class object also. So if you use this dependency injection for that purpose, what you will achieve is your application classes will become loosely coupled. Okay, I'll show you that example. These are primitives, right? Simple primitives I injected. Now let's go with one more example to try with secondary or another class object dependency injection. Okay, so let me create one more project. Setter dependency injection for references. References in the sense secondary data types. Same thing, right? Create a project, add library, go to build path, choose class path, add external jars, copy into your class path, go here, create packages first. I'll create 3 packages. In general, application will have web package and service package and DO package, right? Let me create 3 packages similarly here. Form dot, okay, ds dot web for controller class. I'll put controller class there. Form dot ds dot BU, I'll put business classes here. form.ds.dao. I'll put DAO class here. I'll not create real business and DAO and web. I'll just create simple this car fuel example. Consider, for time being, consider fuel as a DAO class. DAO means database operations we do, right? So similarly, this is the last layer. Okay, so fuel class. Consider this one as a simple DAO class. Set fuel name. And here I have one method, public void print fuel. Now I want to use this fuel in engine class. Engine is my business. So create an engine class. Engine class, now it have secondary dependency. Here when we see fuel class, it has simple primitive dependency. Here this engine is having now another class dependency. So for anything, right, to pass these values, we need setter method. So here also we need a setter method, set fuel. Now my engine class is having one method, public void start engine. Okay. Start engine. And from here I want to call fuel class print fuel also. I want to understand which fuel it is using. Now I want to call my business. So business is calling DAO and business will be called by controller. So this is my controller car class, and here I want to call engine. So private engine give a setter method to inject this engine also. This is also secondary type. Only I have fuel name as a primitive, and engine class is also having secondary type dependency, and car class also having secondary type dependency. Now try to call public void start car. Start car, and from here I want to call start engine, and engine internally will call print fuel. Now I need to create these three objects: fuel object, engine object, and car object. And fuel need to be injected into engine. Engine also need to be injected into car. Let's see how to do that. So first go to your XML file. Start creating your bean classes first. Bean ID. Yep. For fuel I'm using F ID and the class name form.ds. It is there in DO package DO.fuel. This is my class name, and I have a setter method. You know, to call setter method we use property tag. Property name fuel type or fuel name. The property name is fuel name. So just give the property name here and pass value. Petrol. Now another bean ID engine class name form.ds. business classes dot engine. Now here I also have a setter method. Here also I have a setter method, property. What is the setter method name? Set fuel. So I'm passing fuel here. So call set fuel. And what you need to pass here? Now I should not use value. Value equal to which value you need to pass? There is a secondary dependency. I need to pass fuel type. This fuel type I need to pass. As I have already created the fuel type object here, using this ID you can pass it here. And to pass you should not use value. Instead of using value you should use reference of fuel. So first container will create this object and this ID will be injected here into this setter method. So whatever object they created, that object will be injected into this reference variable. Okay, and now create engine class be ID. Okay, car class create car class. Already we have created engine com.ts.f.car. So car class also having dependency of engine. The setter method name is set engine. So here call property, setter method name is set engine, and here you need to pass a reference of engine. What is the reference of engine? E. The reference of engine is E. That's all. Now my container, two jobs done. One, object creation of each class, fuel class object, engine class object, car class object, object creation of three classes has been done, as well as the dependency injection also completed. Fuel class is having the fuel name dependency that is injected. Engine class is having fuel object as a dependency that is also done. And car class is having engine class dependency that is also done here. So the container job is done. I mean, the configuration wise is done. Now try to load it into your application and try to get the car class object. Container dot get bean, get the car class object. Get the car class object here, whichever is created by the container. I'm asking container provide the car object and call the start car method. When I call the start car method, what it should do? When I call the start car method, it should print start car. Then next, the flow should go to engine. So if you see here, start car printed. Now the flow will go to start engine. Here what it should print? Start engine. So the start engine printed. Then from here the flow should go to fuel. So here it should print fuel name, whatever we injected, right? So here it is printing fuel name, the injected value petrol. So this is how you can inject primitive types and as well as secondary types using setter dependency injection. The same thing we can achieve using constructors also. Okay, so that we will discuss tomorrow. Okay, so yeah, let me stop the recording. Okay, yeah. So anyway, tomorrow we'll discuss the constructor dependency injection and what is the difference between both of them, and we will see how we can make classes loosely coupled. Okay, so that's all for today. I have an appointment in the passport office. Okay, I have to quickly move there. Tomorrow we will start. I want to ask you guys if you can able to join by 7 o'clock. We can spend little more time as you all need to leave by 8:30.
Yeah, okay. Yeah.
Is it fine with
Hello.
everyone? Yeah.
Sir, which Eclipse version and Java version you are using?
Sorry?
Which Eclipse version you are using?
Acha, Eclipse version. This is 2019. Let me see. Yeah, 2019 06 4.12. Use any version. There is no such restriction. You can use any version. Okay.
Okay.
Later, right? Once we start with Spring Boot, we will go with this STS, latest Spring Toolsuit version. Or else you can directly download STS and practice in STS itself. Again, that is also kind of active for me, right? You can use STS directly. There also you can do the same thing.
So I want these examples. Here I want to take it.
Yeah, please share me your email IDs if somebody is new. Otherwise, all others email IDs I have. So please ping me your email IDs in the chat so that I'll send these examples and jar files today.
Okay.
Okay, so only one is new for today's session. Okay, Hemant.
I have sent mail ID to you on chat box.
Okay, yeah, I'll copy. Are we guys fine to attend 7 o'clock?
Yeah.
Yes, we can.
So
Is it fine
morning
with everyone?
early
Yeah,
in the
from
morning.
Fine.
Yeah. Okay.
Because we need to cover these topics in very less time, that as it is fast track session. If we can spend at least 1.5 hours or 2 hours, right? We can able to cover good content instead of rushing in the last minute.
Okay. After completion of this class, if there is any possibility, or if you can able to share three questions or like this, anything on the topic whatever we have discussed.
Presentations you want?
Along with presentations, any interview questions or something important things. To be
Sure.
remembered.
Yeah. Topic wise, I'll prepare so that helps. Even in after session,
if you can share also, it is very much
correct. So after every session, we will spend at least 5 minutes. So what are all the possible questions may come? Are we covered for the questions or not? Also, we can see in the session itself, so that we can conclude from the interview point of view also.
Thank you.
Sure. Yes.
Thank you.
Yeah, that we will do.
Thank you. So tomorrow by 7.
Yes.
Okay. Sir, till time I have not given permanent link for the meeting.
Yeah, you will get. Even today also we joined for the demo. A few people are asking for one more demo session, right? So that's why we joined here. Yeah, I'll follow up with them for sharing the actual link for the regular sessions. Okay. So only few of them, I think, they have paid for this. So once getting the confirmation from any, right, what they'll do, they will generate a link and they'll share. And as I said, right, you can get these demo videos and all from here, from this YouTube link. You guys can go and see what happened yesterday and day before yesterday sessions. Once after this session also, right? Yes, you will get all the videos, all the recordings in real time. They are uploading. Even we are not doing any uploads. Automatically, they are uploading into this channel that you can able to access from there. Okay.
Yeah. Okay.
Yeah. So maybe these demo sessions are uploading here. So once after connecting into the regular link, right? Another videos link you will get. So those videos also you can able to see. These all are private videos, okay?
Okay. So these YouTube link is permanent.
This demos one, I think everyone can access, but once we go to the regular sessions, right? There, I think they might put some restriction only for so and so users. They will give the access. I mean, whoever pay and join, right? For them, they will give the access link. Maybe if that is shared with anyone, they can also able to see, but I'm not sure.
Yeah, okay.
Okay, but everyday recording also you will get for your lifetime, I believe.
Yeah, okay.
Yeah, that is the benefit with this session. Generally, others are not allowing to record their sessions and to share, but here I'm trying to record and share my sessions. If that can help you, or in future also, right? You can go and see, or you can refer your friends also. Yeah.
Okay.
So thank you guys. I'm running out of time, so I need to leave. Okay. We'll catch up tomorrow,
Thank you.
7 o'clock.
Thank you.
Okay. Yeah. Thanks all. Good day. Bye.